Hi, everyone. Welcome to Webcast Wednesdays. My name is Grant Steinfeld, and I'm here today with Max Shapiro, and we're going to talk about an exciting project we've both been working on called Bee Travels. So welcome, Max.
Hi everybody. Thanks for having me.
Sure, this is really exciting to be talking about our project together. So Max, you started this project a little bit before I joined. So could you please describe how this project has evolved?
Sure. So before I talk about how it evolved, let me explain what Bee Travels is for those that don't know. So what Bee Travels is it's a cloud container-based demo application that runs in Kubernetes, OpenShift, and other cloud-native technologies. And at its core, it's a polyglot microservice demo application that showcases best coding practices, high quality code, and cloud native technologies. And what it is it's a travel application. So you'll be able to book hotels, flights, car rentals, and basically come up with an itinerary. It's similar to like hotels.com or other websites like that.
Wow, that's really cool. And I think what I've gleaned from this project is, as a developer myself, whenever I've started out and just been tasked with building a system, I've always gone off and looked for precedents and found someone else's code where they'd written something similar, and then I went ahead and I studied their code and maybe used pieces of their code to build my own system. So what we're doing here is really exciting. Is we're giving people an example application and an example set of stacks and recipes in order to choose the right technologies and the right stacks in order to build an application that fits their needs. So I know you have a nice diagram showing off the smorgasbord of technologies. So maybe you could talk a little bit about the motivation behind the project and how you came about to choose these technologies.
Sure. So the motivation for this project came last year when myself and fellow New York City developer advocate Mofi were discussing that we did not have a large-scale demo application for them to take to workshops. And so I had an idea where we could create our own large-scale demo microservice application similar to Google's, and we could essentially kill two birds with one stone in the sense that him and other developer advocates could take this application or parts of this application and use it in their workshops and take it to clients and events and stuff of that nature. And myself and you, Grant, what we can do is for the work that we do is create code patterns and blogs and articles and from this application, and basically taking snapshots of it to showcase specific technology.
Right, and that's absolutely, I think that's what a lot of people are looking for. And the fact that it comes from a single source, meaning it's coming out of our development team, and that it's also publicly available as an open source project, it just means developers can mix and match and learn and try out different kinds of technologies and also learn from them, because a lot of these projects and aspects of Bee Travels are being turned into code patterns and tutorials and articles, and that also increases the quality of the content.
Definitely, yeah. And in this development process that we're doing, we have multiple versions of this application. So we've already finished the first version, and we're in the process of developing the second one, and we have a third one on the way after that. And one of the reasons that we're doing versions is to showcase versioning in history.
Right. It's very slick, and I love the way you use the Paul Rand, the B. In fact, my T-shirt, well, if I just tilt my monitor ever so slightly, there's the B. So where will you be traveling? I really love that you did that, Max. And I know you have some nice diagrams to show as well now. So maybe you could dive in and take us through your demo artifacts that you've put together.
Sure. Yeah. So before getting into the nitty-gritty, let me first explain what services are included in this application and ones that we're planning on including. So here is a list of the different microservices, and there's quite a number of them, and that's because we want to create a large-scale application. And as I mentioned, we've finished the first version, and in that version, that includes the UI, the destination service, the hotel service, and the currency exchange service. So, and every other service here will be created in the second version and the third version going forward. And we're in the process of doing that right now. So with the first version, this is the architecture diagram for it. And zoom out. So here, as I mentioned, we have the UI, which communicates with the currency service, the destination service, and the hotel service. And I will show a demo of how to run, or of this application, and how to deploy this application too in just a quick second. So let me go ahead and switch over. So before I get into that, I first want to take everyone through our project and our repo to kind of show the structure of this. And because this is a work in progress, stuff in here will be changing from the time this video is recorded. But for now, I'll show what we have. We have different languages. As I mentioned before, this is a polyglot application. And what I mean by that is we've created this application in multiple languages. And this allows us to cater to many different developers out there because, for example, not every developer uses Node. So by creating all these different languages, we'll be able to showcase best in practice code and technology stacks for each of these languages. So in here, we've got our Node version, which is the main language that we're in the middle of developing. We have a Python version and a Go version, and eventually we'll be creating other ones. We have a data generator repo here, which houses the data generation because we're using fake data, and it also populates different databases with our data. And like I mentioned before, we have different languages, and that caters to different developers. And in this case, this also caters to many developers in the sense that not everyone uses Mongo. So for example, we have like Mongo and Postgres. So we've got the SQL, NoSQL databases, and many other different types. And here we have our config repo, which houses our deployment scripts and files. So you'll be able to deploy anything that you like. And on top of that, we've also created what we call the deployment wizard to simplify this process and allow you to, in a way, choose your own adventure when deploying this application. So let me show the wizard. So here's the wizard, and it allows you to deploy to the cloud, and you can choose here if you want to deploy it to Kubernetes, OpenShift, Knative, it's up to you. So I'm going to choose for this demo Kubernetes. Now it's asking for which version of the application I want to deploy. I'm going to choose version 1 because that one's already been completed. And here are the different services that you can deploy with version 1 of this application. So what I'm going to choose is the Node version of destination, the Node version of hotel, and to spice it up, let's do the Python version of the currency exchange. So I'll go ahead and hit deploy. So as you can see here, we automatically generate the YAML file for you. or deploying this to your Kubernetes cluster. So it has all of the services here. And the way to deploy this is you can either copy this to your clipboard or download this file and make sure that you are connected to your Kubernetes cluster. You can run this command here, and you'll be able to deploy it to your cluster. And I'm not going to run through that right now, but I do have a working version of this application on OpenShift.
This is really cool. Yeah. And we'll take a look at that in a second, Max. I just wanted to interject here, if that's okay, and just mention, so if you were to do this yourself, and you could write YAML yourself, you'd be up for quite a lot of work, because YAML is white space dependent, and you're very likely to make an error if you don't have some sort of linting set up in your project for YAML, as well as what you've also shown here is you've taken all these different technologies and you've created a recipe that people can follow. So instead of me having to think, oh, should I use Node? Should I use MongoDB? Should I use, should I use Kafka? You're giving people a sort of recipe so that it makes it easy for them to get up and running really quickly. And I think that's, this is really what we need in examples and demos, is things should work, and we are proving they work now. And in fact, that's what you're going to show us now.
Right. Yeah. And to build on top of your point, because these are microservices, all they care about is what the API endpoint is. It doesn't matter what language it is or what the data is. All you need is like the connection string or the API, and that's it. And because this is a work in progress, we have not incorporated the data generation or the database part into the wizard, but we are working on that currently. So let me go ahead and show this application running on OpenShift, which I have here. So here is a working version on my OpenShift 4 cluster. And as you can see, here's the UI. It's asking me, where will I be traveling to? So let me go ahead and put in New York. So as you can see here, on the left side, we have all the data from the destination service. So it talks a little bit about New York and shows some pictures and where it is on the map. On the right side, we have the hotel data, the fake data that we've generated from the hotel service. And also over here, we have the currency service implementation, where you can choose different currency to convert this to. So let's just say euros. And as you can see, all the numbers for the hotel prices have changed. And you can also filter the hotels down by super chain. So if you wanted to see only this super chain, you can do that. The different hotels by type. And you can also narrow it down by price. So this is pretty straightforward. It's similar to what you'd see on other travel booking websites. And so that is the first version of this application. As it was previously mentioned, there are a lot of technologies that are being used in this stack. So let me go ahead and show what that looks like. So these technologies are part of the application lifecycle, and this includes the deployment technologies, the DevOps technologies, and also the technologies around coding. And because we're using the best practices, one of those practices in writing your code is test-driven development. And Grant here took the lead on implementing test-driven development in B-Travels. So I'm going to let him talk more about test-driven development and how it was implemented in our B-Travels project. So I'm going to stop sharing, and I'm going to let him share and talk more about that.
Great. Thank you, Max. So yes, indeed, that's a real potpourri smorgasbord of technologies. And yeah, this is exactly right. Trying to find that right blend is really crucial. So in a little bit about myself, so I'm a software engineer for about 30 years now. I've been at IBM for a year and a half, and I've just recently moved into the code pattern and cloud and cognitive code pattern group. So here's, in fact, a little bit of shameless self-promotion. Here's an article I wrote on what are the 5 steps of test-driven development. So I've always used test-driven development and writing unit tests for about 10 years now. So initially, when I started out in software, there weren't tests. There wasn't agile development. And so this is a fairly recent methodology in writing software. So I would highlight the main motivation behind writing tests is creating clean code that works. So of course, all code should work, and we know it does, but maintaining a large code base over time without tests can prove to be difficult. So I'm just going to talk a little bit about, what makes test-driven development really different from not doing test-driven development. So what we do as an agile test-driven development programmer or somebody who's learning the technique, the first thing you want to do is write your unit test first. So writing your unit test first may seem a little counterintuitive in the beginning, but there are various advantages for you to write your tests first. And as we look at the flow of test-driven development, you can see why we'd write the test first and how that plays in. So there are basically 5 steps in the test-driven development flow, and these are them. So what first happens in any software project, as you all know, is you have some sort of ticketing system, some sort of project management tool like Jira or Pivotal Tracker or ZenHub. Any one of those are fine. And here you would take the requests from the stakeholders and diagram and lay out what are the features you want now, what are the features you'd like to have in the future, what are the features actually in progress, and what's been done. So indeed, B-Travels is doing this. We do have our feature request board. You can take a little peek over here at our board. New issues are things that are sort of on the wish list. These are things that have not been considered yet. Backlog are really requests that are waiting to happen. These are the things that are in progress, and you can see who's doing what, and you'll see me showing up here. There I am with my underwater camera. So I'm working on the payment Node.js service right now. These are the things that we've done, and then of course there are things that are deferred, and then items that are completely closed out. So I would then choose something off the board. I might be hinted at by my manager, or Max may say, hey, we really need this right now. So I'll take that feature request, and then I'll translate it into a unit test first. So I'm taking an exact request and writing a test for it. So here's a good example of a requirement that you might see. And this is saying we're going to look up a currency name and look for a 3-letter country code by passing into a country name. So this would be my request. It would show up in the ticketing system. I would then first write my test. So here's my first stab at writing a test. I'm using Jest in Node.js in order to do this. And it uses this describe syntax. So the describe pretty much takes what is in the requirement. So I've taken my requirement and put it into my code, my tests, and this is now going to start forming some sort of programmatic documentation for what the system actually does. So here you can see it repeats exactly that. We're going to pass in the country South Africa, and it should return the metadata for that country. It is South Africa. So here we have a function called get currency name and code. Now remember, I haven't implemented this first. I first write the test. So this implementation doesn't even exist yet, but I put it in my test, and I know this test will fail because this function hasn't been implemented yet. And I know enough in my head that I do sort of expect what I expect back from this kind of function. I expect to see, oh, okay, the country we know is South Africa, but I'll like to see the currency name, which is the South African rand, and the universal currency code, which is ZAR. So I write this test, and then my test will go red. So when your test goes red, that means your test failed. So I would write the test, and the test would go red. And then I would go ahead and write some code to implement that test. So in order to do that, I'm going to write the barest minimum of the code to make this test pass. And this is the main reason for that is really to get the plumbing working, right? So to get the classes and all the import statements teed up.
Grant, can I ask you a question?
Of course. Sorry, please go ahead.
No problem. So I've noticed that you've written your test first with the expected values. So why is it better to write your test like that first instead of just implementing the code and then testing it after?
Exactly. I mean, you could just implement it in the code and not write tests. And in fact, we all have, and I have in the past, and that is the habit of most software engineers. But if you do write your test first, there's a couple of advantages. One is you feel secure and you know that this piece of code has a test around it. And as you add more functionality to your application, you're going to, a real, like B-Travels eventually will probably have close to 1,000 tests. So that means is if something changes and you try to refactor or you introduce a new service to get a currency exchange, it might break things. And you want to see those things break as part of your Git check-in. And that's really powerful because you want to know if things are breaking. You want to see your tests fail rather than your users coming back and shouting at you. So I think that is definitely one of the good reasons. The other one that stands out in my mind is, let's say all I'm doing here is writing this test. I then go implement it. Here's my naive implementation. So here's my actual code. It just returns back, like I said, the expected value. So what this means is I can hand off the actual coding task to pull back the currency name and code, say from an external web service, right? Like what I did. But someone else on my team now can work in parallel and could go off, write the code, and not be a blocker for the general development. So they can carry on, and I can carry on, and we can sort of double our efforts and move twice as fast.
That makes sense, because especially like if it's an API endpoint, they'll know what to expect. So yeah, definitely you guys could work in parallel because that's all they already know what they're getting out of the API anyways. So that's
right. Yeah, exactly. And another really key thing is most people, when they write an application, they'll have a main method, and all applications indeed do have an entry point like a main method or function. And in that main method, they'll typically write, go get me currency name and code. They'll hard code in some like useless code just there to test something. They'll have to run the whole application just to test this small function. And that's really a productivity, it's not good for productivity. So you want your tooling set up so that your tests run as you're working. So just a few points here I just thought I'd put in here. This would still be red. I just needed to do my import and exports. And then actually my test passes and my bar goes green. And then here, yeah, of course, here the ideas where we've just reiterate, right? So we've got a bare bones implementation. We can work in parallel. Requirements are naturally translated into the test. So the self-documentation shows up. We also are forced to write a little more modular code rather than sort of flocking large, long methods and anti-patterns. And as I said, it obviates the need for the main entry point. So this is the cycle. My tests pass, and then I refactor, right? So either I do the refactoring and I actually hook up the service, or someone else does it, but the test is there, and when they run the suite, it goes through these tight, small iterations around the code implementation.
So can you show us where this test, or where in your code you wrote the code to make this test pass?
Yeah, absolutely. So I'm going to show off a few things here. So I've set up my tooling. So this is a Node.js project. It's very simple. It has a package JSON. It has a bunch of Node modules, and it has something called Jest. So we're using Jest for unit testing. And what I'm able to do now is run my Jest in a watch mode. So my unit tests are running all the time. So I'm going to show you the exact test that we try to run in the real world. So here we were going to pass in a country that we knew existed, and I believe this is South Africa. So this is the exact test we just saw, and we expect this data back. Now let's put in a country we know that may not exist, or the spelling is incorrect. So I'll just replace the C with a K, which is an often mistake because we have multiple languages in South Africa. So if I save this file, notice my tests are running without me having to go and run my tests. And what's really neat is I can actually see that one test failed. So I've gone red, and you can actually see, oh, that's the problem. There is no country found for this country name. So there it is, no country found for South Africa. So now I can go in here and I can modify my test and save it. So this is immensely helpful. And this you can do in Node.js, you can do it in Python, we do it in Python as well, and you can do it in various other places too, in other languages like Go and Java all have these functionalities. So you asked me where the implementation was. So here's the implementation, and so here it is. It's a fairly simple function. Takes in the country name. Notice we're no longer hard coding the response. We do have some validation checking. We read the CSV file. So all our data in this case, there's not many country codes. Actually, I think there's maybe 120. So CSV file is fine. We are now using the data find. Notice we're using an inner closure here. We're looking for when the row country lowercase is equal to the country name in lowercase. We get back the country row.
Brian, can you try and zoom in on this? I think some people are having some issues seeing this.
Is that better?
I think so, yeah.
Okay, cool. So here we are in Visual Studio Code in Zen mode, which is really awesome. So again, there we go. We have a nice lambda, so an inner function call. We find the country row. If we don't find it, we throw a not found error. Otherwise, we return back the country row, which indeed is what we saw in our unit test, was that dictionary of country name and currency code and a currency name. So that was one example of how we did this. And maybe Max, you can say a little bit about the bug we found with the US dollar. I think this was really putting test-driven development in action.
Yeah. So when I was playing with your currency service, I noticed when I put in USD and I was trying to find which countries had USD, I was only getting back one, which was American Samoa. And I was not getting back the United States of America or other countries that do use USD for their currency. And so as a result, I told you that. We made an issue on the board, and you went ahead and made the changes in your test, which you can show us, and now it's working as intended.
Right. And this is actually one of the beautiful things about test-driven development is when you have a bug emerge, you know, at first you're like, oh, I've got to fix the bug. So you go into your code and you fix the bug, but that might have side effects. It might affect other tests. It's not the test-driven approach. So what you do when you have a bug is you first write a test that'll actually reproduce the bug. So in our case, we did take a look here for this US dollars, and originally it just returned back a single country. In fact, the top item in the list, which is American Samoa. So I wrote the test to break and make my code go, my test hit the red phase, right? So I was actually to reproduce the bug broke, the test broke, indicating there was a bug. And then I went in and refactored get country and currency code to return back multiple countries rather than the first country. So we don't exactly have the original test because the test actually refactored and became this. So this indeed is the test that I ended up writing in order to indicate this case that, in fact, the US dollar is used in multiple countries. I don't even know if my screen's big enough. Well, there you go. So, you know, it shows up in, you know, over a dozen countries. And this was actually quite interesting to me because I didn't really even know that there was a country called, you know, this country. I didn't even know how to pronounce it, Sintestrius. If anyone here on the call is on that, maybe they could tell us about it. But I know about Saba, as you know, and of course Zimbabwe is very close to where I'm from, which you could probably guess. South Africa is my accent. Anyway, so here are my expected countries. I knew this was my list of expected countries, but this function hadn't changed yet. So when I run this test, it would also still be red. So what I'm doing now is I'm teeing up my test to give me what I expected. And this is what you indeed expected. When you put in US dollars, you expected to see back, you know, all, you know, 18 of these countries. So this is great. So if this all works well, I should be able to go straight to my function. That's great. Okay, look at that. Visual Studio Code is working as expected. So here, I had to do a little bit of a sort of a brute force approach to actually find where my currency code equal to the currency code and return back the country. So I'm doing a for loop on each row in my CSV file. I'm getting the row, I'm checking out the currency code in the CSV file data, and then checking to see if it matches. If it matches, I increase my counter, and I create this dictionary, and then I merely push the row country into the list, and then I check the list, and if the list's empty, well, then that currency code is not found. Otherwise, I just return back all my rows, and this is my output. And that indeed is what we expected to see in my test. So here we fixed a bug with a test-driven methodology.
Oh, that's really cool. And it's good to see that entire process too.
Yeah, I'm pretty psyched by it. And indeed, I had a mentor in a company I worked at previously who showed me a lot of these test-driven development aspects. And I've learned it from a couple of mentors, not only in Python, and I've also learned it in Erlang and various other languages like PowerShell as well. So this is really neat. So I would just draw attention to this article. It pretty much is exactly what we've done, right? So we understood the bug request. We translated it into a test. We have hot reloading set up, very well recommended. And if you clone our repositories, you can get all of this tooling out of the box. The unit test will run and fail as the code's not implemented, or the code is erroneous in our case. We then go fix it. So we we go and write the code here, number 3. It passes, and then we do this cleanup. So this cleanup and iteration process is merely polishing and improving our code. So refactoring is essential in modern software development, as it makes our code easier to read, it simplifies things, it reduces things like duplication. So if I'm constantly writing the same code over and over again in each function, it's a prime candidate for refactoring. So if you're going to
also to add to your point, Grant, by doing test-driven development, yes, it does take longer in your development process, but with that, you do get higher quality code out of it. You don't need as much documentation, and you also have a better understanding of what you're writing and how it works, because you already know what it's supposed to do.
Yeah, exactly. And I have to say, a lot of managers will be like, oh, why are you not writing production code? But in fact, you're writing a high quality way of making sure that the code stays high quality. You can share this code with your colleagues. If I, for some reason, had to leave the company where I was working, the next developer who came along would have a much easier time understanding what's in the system. And mainly because feature requests often get out of date and out of sync. And it's hard to go back and look at your feature requests and translate it to code. So there's this great relationship between the feature request and the actual implemented code. And I have to say, it's a little hard to get started with test-driven development, and a lot of people are resistant. And I indeed was one of those people, and it took me a while to get into the groove and become an advocate and test-driven development developer. It's a bit of a mouthful, but for me to be a proponent of test-driven, I don't see myself writing code without unit tests and tooling. So I just wanted to show a couple of other things for code quality. I know, Max, you mentioned we're trying to create a best of breed code base here with B-Travels, and I know we've recently been working on new tooling in order to make sure this happens. But I did have a quick picture I wanted to show here. I won't actually run it, but notice here when I run a git commit. So this is called a git commit pre-hook. So what this means is, even before I commit my code into source control, like GitHub, a hook will happen. Now, what will happen here, you can see errors are happening, and two pieces of code, two node libraries are running. So we have a library called ESLint, which is a linter, and we have Prettier, which is also a code syntax checker. And you can see things here. You can notice that there was an unexpected token. There's a missing semicolon. And you can also see here const is spelled incorrectly. It should have a T in it. So this is really helpful. So you don't even hit your GitHub. This happens before. So this is another way to help you improve the quality of your code, as well as productivity, right? So if I hit Git, I did my commit, I would have to wait for Jenkins or some other job to run, like Circle CI or Travis. And that, unit tests can, as you know, they can take like minutes to run. And this takes seconds because it's all running locally. So, as a whole, by having my tooling set up, I'm really way more productive. So I just wanted to show you guys that. And this indeed is a code pattern. All of our work can now be seen on developer.ibm.com, or at least most of it. So encourage everyone to take a look there. I think that's pretty much all I needed to say about testing. Did you have any more ideas on the testing we're doing, Max? Or are you are you a convert yet to write unit tests for your code? Or I know you.
Well, I think after sitting here today and working with you these last couple of months on this project, I have seen the benefit of using and implementing test-driven development. So yes.
Great. Well, thank you. And you know, I'm always open to, you know, helping people out and point in the right direction on how to improve your coding quality. And you know, this is a constant moving, you know, self-improvement way of thinking, and you constantly get better and better. And tests almost become irrelevant in the sense of time. They actually, you write them so quickly, and the fact you're not writing main functions to test your code, or running the whole application just to test, like, you know, a small like credit card, you know, validator, doesn't make sense anymore, right? You know, my application took 20 minutes to run in OpenShift just to find out that my validation code was incorrect. So yeah, I hope we've shown people a little bit of you know, this methodology. So I see we have about 15 minutes or so left. I was just wondering if anybody had any questions, feedback, comments on what we've been talking about. Please feel free.
I'm looking at the chat right now, and I don't see any questions in particular.
Okay. I'm sure then maybe everyone is either a convert already of test-driven development, or we might have scared you guys off and people off.
I'm sure they're all busy implementing test-driven development as we speak.
Yeah, absolutely. So what did I want to say? So yeah, on developer.ibm.com, you know, we do have these code patterns, and at the bottom of each code pattern, we do have some resources. And I would just suggest people go take a look at the resources and all the other code patterns around it. It's actually in our Git repo. So everything's in the Git repo. Everyone's welcome to fork the repos, open up issues, help fix the code. You know, these are open source projects, and we want people to interact with them, give us feedback. And, you know, the whole idea is we were looking for constant improvement and feedback with the work we're doing. So
I do want to make one point now that you're right here. So like Grant, as you showed, there is content on developer.ibm.com, and that content is from this B-Travels project, and this specific repo that he's in is a snapshot of one technology focus or one component focus from the whole project. And as everyone has seen over the last 45 minutes or so, we were able to talk about one piece of this project, which was test-driven development. And from this project, as I've shown, there are many different technologies, layers, and parts of this project. And we could probably have multiple webcasts on this. And it's really interesting, and it's great in the sense that from the initial views and goals of this project, we were able and are achieving those goals of having a large application that we are allowed to, or we can talk about anything about that project and just have a whole talk about it. It's really cool just to have that.
Great. Yeah, absolutely. And notice on these code patterns, you can use the template aspect. So instead of cloning and copying or forking, you can create a template off this repo and be off to the races and actually get started and change the code for your own reasons. I do see we did get one question here from somebody out on the ether. We've been asked, how do we contrast TDD with LDD? So when you're talking about logs, You know, we do log everything in our system. Logging is a best practice for all applications. Sometimes you can't reproduce an error with a test, and sometimes even a debugger can't help you with a test. So logging is there, and it's a really useful way to find issues with your code as well. It feels like it might be more of a it feels like it could be more of some sort of a way of finding errors in your runtime code. So tests are not really useful on the runtime side of the equation. They are useful in the development side of the equation. So
I'll add something to that. As far as like creating your code, it's you can't really base it off of logs because you haven't written the code yet. But what is beneficial about having log-driven development is once you have this in production, or even during development and testing, you can see in your logs, what's working, what isn't working, and then refactor that way. So you can use them together, but in my opinion, I wouldn't start out focusing on log-driven development, and I would start with test-driven development and use log-driven development to help with your development process as you go.
okay, everyone, thanks for joining.